Hello there, Randall Schwartz back again with another tip, trick, or technique from the world of Dart and Flutter. We've all written code that looks exactly like this. You need to hit an API endpoint, so you have a search query from a user, so you just drop it straight into a string using string interpolation and pass it to Uri.parse. It works perfectly in your local tests when you search for Flutter. You ship it into production. But then a user enters something like Dart ampersand Flutter, or searches for a price like #1 choice. Suddenly, your API returns a 400 error, or worse, gives completely unpredicted search results. Why? Because string interpolation combined with Uri.parse is a silent trap for Uri injection and broken encoding. Here exactly is what's happening under the hood. Uri.parse expects a string that is already a fully valid, properly percent-encoded URI. It does not know which parts of your string came from hard-coded paths and which parts came from an unsafe user input variables. When it sees that ampersand inside your interpolated string, it treats it exactly as a Uri component separator. Instead of sending a single query parameter q with the value Dart ampersand Flutter, your Uri structure breaks. It now thinks you have a parameter named q equal to Dart space and a second empty Boolean parameter named Flutter. If a user enters a #, everything after it gets treated as a fragment identifier, completely chopping off the rest of your query parameters from the actual network request. To fix this permanently, you should stop building Uri strings manually. Instead, let Dart do the heavy lifting safely. The cleanest approach when building on a brand new URL is to use the structured Uri constructor. You break the URL down into its logical components, the scheme, the host, the path, and most importantly, a map of query parameters. When you pass your raw, unencoded user input into query parameters map, Dart automatically applies the correct percent encoding rules. Spaces become plus signs, or %20. And ampersands become %26. Your API receives exactly what the user typed, and your application layout never breaks. But what if your base endpoint is already defined as a URI object, maybe perhaps coming from an environmental configuration or an API client-based setup? You don't need to revert to strings here either. You can call the replace method on your existing Uri object. Replace creates a new immutable instance of your Uri while swapping out only the pieces you specify. By passing your query parameters to replace, Dart ensures that your base paths remain perfectly intact while your dynamic arguments are encoded flawlessly. So the takeaway is simple. Uri.parse is for static or already encoded strings. The Uri constructor and Uri.replace are for dynamic data. By making this one small shift in how you build your network requests, you eliminate an entire class of input validation bugs and potential security vulnerabilities. If you found this tip helpful, hit like and subscribe for more deep dive Dart and Flutter architectures, and drop a comment below if you've ever been bitten by this silent interpolation trap. Happy coding!